Greetings children, we are continuing the topic hyperbola. In this lecture, we will study about the pair of tangents, already you know, and from external point we can draw two tangents. Now, what do you mean by chord of contact? So, see children, here I am telling you the equation of chord of contact. So, what is the equation of chord of contact? Hyperbola equation already you know, x square upon a square minus y square upon b square is equal to 1. Shape of the hyperbola also you know, this type shape you will get. This is a point, that is the external point of the hyperbola. From this point at most two tangents you can draw. Suppose one tangent is this one, another tangent is this one. We touch the hyperbola at 2 points. One point is say A, another point say B. If you join the A and B, this is known as chord of contact. So how will you get the equation of chord of contact? You know children, S represents x square upon a square minus y square upon b square minus 1, and t you will get when x square replaced by x1 upon a square, y square replaced by y1 upon b square minus 1. Then equation of chord of contact is t is equal to 0. This is a direct formula to find the equation of chord of contact. It means x1 upon a square minus y1 upon b square minus 1 equal to 0 or equal to 1 you can say. This is known as the equation of chord of contact. Same type equation you got when you are finding the equation of tangent. But in that case point P lies on the hyperbola. Here point P is outside the hyperbola. So t is equal to 0 here represents equation of chord of contact. Clear this? Now we are taking one example based on this. In this example, if tangents to the parabola y square is equal to 4ax intersect the hyperbola x square upon a square minus y square upon b square is equal to 1 at P and Q, 2 points, then locus of point of intersection of tangents at P and Q is. So we have to find out the locus of the intersection of the tangents at P and Q. Let us suppose point of intersection is H comma K. This is the point of intersection. From this point it means we have drawn the two tangents. Then equation of the chord is, so equation of chord of contact of hyperbola is, this is the equation of hyperbola, so t equal to 0. T means x into h upon a square minus y into k upon b square is equal to 1. That is the equation of chord of contact of the hyperbola. Now this chord of contact is a tangent of this parabola. So convert into standard form, so you will get yk upon b square minus 1 plus xh upon a square. Simplify this, you will get y is equal to b square upon a square into h upon k times x minus b square upon k. Now this is the tangent of the parabola y square is equal to 4ax. Now any line y is equal to mx plus c will be a tangent to the parabola when c value is equal to a upon m. So we have to apply this condition, c is equal to a upon m. Value of c is here minus b square upon k, a y square is equal to 4ax, a as it is, upon m, coefficient of x is m. So you can say b square upon a square into h upon k. Simplify this, you will get minus b raised to power 4 into h is equal to a cube multiplied by k square. Further simplify, you will get a cube k square plus b raised to power 4 h will be 0. Now we have to find out the locus of h and k. So what is the locus of h and k? Replace h by x and k by y. You will get b raised to power 4 x plus a cube y square equal to 0. That is the locus of h and k. So you can check which option is your correct. B raised to power 4 into x plus a cube y square. So your B option is the correct option. Now equation of the chord if midpoint of the chord is given. So hyperbola, there is any chord, say PQ, its midpoint M, this is given to you x1, y1. Then what is the equation of the chord? So we are finding here now equation of chord whose midpoint say x1, y1 is given. Equation of hyperbola is x square upon a square minus y square upon b square is equal to 1. Now we call S. S means x square upon a square minus y square upon b square minus 1. Now t, what do you mean by t? X is replaced by x1 and y square replaced by y1. That is known as the t. S you know, t you know. Now value of S1. S1 you will get when x is replaced by x1 and y is replaced by y1. This is the value of S1. Now equation of chord whose midpoint is given by S1 is equal to t. So put the value of S1 and t, you will get t value is x1 upon a square minus y1 upon b square minus 1, and value of S1 is x1 square upon a square minus y1 square upon b square minus 1. Minus 1 will be cancelled. So x1 upon a square minus y1 upon b square is equal to x square upon a square minus y1 square upon b square. This equation is known as the equation of the chord whenever midpoint of the chord is given. So we will use direct this formula to find the equation of the chord if midpoint of the chord x1, y1 is given. In this example, based on the previous topic, this is the locus of the middle point of the chord of the hyperbola. This is the equation of the hyperbola is given 3x square minus 2y square plus 4x minus 6y equal to 0. That is parallel to the y is equal to 2x is. So what is the equation of the chord if midpoint of the chord is given? Let us suppose midpoint is h comma k. Then equation of the chord whose midpoint is h comma k is given by t is equal to s1. Put the value of t and s1 here. T 3xh minus 2yk plus 2x plus h minus 3y plus k. That is the value of t. And s1 when you place in place of xh in place of yk, that is 3h square minus 2k square plus 4h minus 6k. Simplify this, you will get 3h plus 2 times x and y terms minus common 2k plus 3 times y. Now constant terms 2h minus 3k minus 3h square plus 2k square minus 4h plus 6k equal to 0. All these are constant terms. Now this chord is parallel to y is equal to 2x. These two chords are parallel. Say second equation, first equation. You know, two lines are parallel, then what is the condition of this? Their slopes always remain same. So what is the slope of the first one and what is the slope of second? From equation first, you can find the slope. Its slope will be minus times x coefficient upon y coefficient. So I am writing here 3h plus 2 upon 2k plus 3. And slope of this is given here 2. Simplify this, how much you will get? 3h plus 2 is equal to 4k plus 6. Transfer all the terms to the one side. 3h minus 4k minus 4 equal to 0. What is the locus of h and k? So locus of hk is 3x minus 4y minus 4 equal to 0. That is the locus of this h and k point. Now match your answers. So 3x minus 4y is equal to 4 is given here. That is C option is the correct option. Now children, we will discuss about the asymptotes of the hyperbola. What is the asymptote? You know hyperbola, standard form of the equation of the hyperbola is x square upon a square minus y square upon b square is equal to 1. See its shape like this type. Now a line which becomes closer to the hyperbola but it will not touch to this. It becomes closer but do not touch this. This is the line which becomes closer to the hyperbola but ये क्लोज होती जाएगी, इसके एक्सपेंड करने पर क्लोज होता जाता है इसके, पर इसको टच नहीं करेगा ये. टच एट इंफिनिटी, द लाइन विच टच द hyperbola at infinity or touch the curve at the infinity is known as the asymptote. So we have to find out the equation of asymptote. You know children, equation of the hyperbola is this. Then what is the equation of asymptote? This is the line passing through the origin. One more line we can draw from the origin that also becomes closer to this. Equation of this line you will get y is equal to b upon a times x, and this line you will get y is equal to minus b upon ax. So there are two equations. One equation is y upon b is equal to x upon a, or you can say x upon a minus y upon b equal to 0. First equation. Second equation, y is equal to minus b upon ax. So I can say y upon a minus x upon a, or x upon a plus y upon b equal to 0. These are the two equations of these two lines. The combined equation of these two lines is given by x upon a minus y upon b equal to 0 and x upon a plus y upon b equal to 0. If you multiply these two, you will get x square upon a square minus y square upon b square equal to 0. That is a combined equation of asymptotes. These two straight lines which touch the hyperbola at infinity. So this is the equation of asymptotes. Now difference is here only the constant value. So remember this, the equation of the hyperbola and combined equation of asymptotes, there is difference of only constant term. Constant term का difference होगा equation of hyperbola और pair of asymptotes. तो दोनों asymptotes के equation जो आएगा उसमें और hyperbola के equation में केवल constant का difference रहेगा. इस concept का हम use करेंगे asymptotes के बारे में और examples अभी लेते हैं. Children, I told you directly the equation of asymptotes. Now I am telling you the derivation. How will you get the equation of asymptotes? Let us suppose y is equal to mx plus c is the equation of asymptote. Put the value of y in the equation of hyperbola. You will get the equation x square upon a square minus mx plus c whole square upon b square is equal to 1. Simplify this further. X square upon a square minus m square x square upon b square minus c square upon b square minus 2mcx upon b square minus 1 equal to 0. So x square, you can say coefficient of x square will be b square minus a square m square upon a square b square times x square. Coefficient of x 2mc upon b square into x, and constant term c square plus b square upon b square equal to 0. Now this is a quadratic in x, so you will get two roots of the x, but both roots should be infinity. That value you will get when coefficient of x square, that is b square minus a square m square, should be 0, and 2mc is also 0. Then you will get the equation of asymptotes. So you can see from here the value of c is 0. Now from here you are getting the value of m square is b square upon a square, or you can say value of m is plus minus b upon a. Now you got the value of m is plus minus b upon a and value of c is 0. So value of m, substitute over y is equal to mx plus c, and value of c. You can see here m is plus minus b upon a. So m will not be 0, only c will be 0. So put the values here, so you will get the equation of asymptotes. So y is equal to plus minus b upon a x. C ka value 0. This is the equation. I have written separately plus sign, and this is minus sign, then this one. Combined equation, I already told you the difference between the equation of hyperbola and combined equation of asymptotes, that already you know. Now example based on the asymptote. The asymptotes of the hyperbola. The equation of hyperbola is given here, xy minus 3y minus 2x is equal to 0. This is not the standard form. Now how will you get the equation of asymptotes of this hyperbola? You know children, the difference between the pair of asymptotes and equation of hyperbola. What is the difference there? Only the constant term. So it means if constant term I will change, there is no constant term, I am taking a constant term in the equation of asymptotes. So equation of asymptotes I have taken as a 3x plus 1 constant c, 0. This is the equation of asymptotes. If this is the equation of asymptotes, it means it will represent a pair of straight line. What is the condition that any quadratic equation, any second degree equation will represent a pair of straight line? You know that I am writing here again ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. That is known as general equation of second degree. Now it will represent a pair of straight line if delta, what do you mean by delta? ABC FGH, this value should be 0. Now you have to identify the values here first of all. So value of A is 0, value of B is 0, value of h is half, value of f is the coefficient of 2y, so minus 3 by 2, value of g is minus 1, and constant term c is c here. Put these values in this and find out the value of delta, that is a is 0, b is 0, c is c. Value of f minus 3 by 2, value of g minus 1, value of h, so half minus 1 minus 3 by 2. Now expand this determinant, you will get the value of delta, either 0, it should be a 0. Now expand this, it becomes minus half, first term is 0, second is minus half, it becomes half c minus 3 by 2, then minus 1 multiplied by minus 3 by 4, that should be 0, simplify this, minus 1 by 4c plus 3 by 4 plus 3 by 4 equal to 0. So value of c is, you can see c is 6, c का value मिल गया आपको 6. Now put the value of c is here. So what is the combined equation of asymptotes? Xy minus 3y minus 2x plus 6 equal to 0. That is the equation. But in the options they have given the single straight line. So it means you have to factorize and find out the equation separately. So if you take here common y, you will get x minus 3. Here common 2. Further take common x minus 3 into y minus 2 equal to 0. So there are two equations we are getting, x minus 3 equal to 0 and y minus 2 equal to 0. Now check which option is your correct option. X minus 3 equal to 0. So A option is the correct one. And they have given y minus 2 also 0. So this is option. So this is a correct answer is here. Okay, you have two correct answers. So you have to write down both. Children, next example based on the asymptote 8. The product of the lengths of the perpendicular drawn from any point on the hyperbola x square minus 2y square is equal to 2 to its asymptotes is. From hyperbola there is a point. From that point we have drawn two perpendiculars on the asymptotes. So what is the length of perpendiculars and their product? So we have to find out what is the product of their length of perpendiculars. So first of all, write down the equation of hyperbola in standard form. So divide by 2, you will get x square upon root 2 square minus y square upon 1 square is equal to 1. This is the standard form, x square upon a square minus y square upon b square is equal to 1. So value of a is here root 2 and value of b is 1. So now suppose parametric coordinate on this hyperbola, that is a sec theta. So value of a is here root 2 sec theta and b tan theta. B is 1, so it becomes tan theta. This is the point on the hyperbola. Now what is the combined equation of asymptotes? So equation of asymptotes is this one, then it becomes equation of asymptotes. Only difference of the constant term. This is the equation of asymptotes. Now separate equation of the asymptotes you can find x upon root 2 minus y equal to 0 and x upon root 2 plus y equal to 0. These are the two equations of asymptotes. From this point, draw the perpendicular on this asymptote. Say P1 is the length of perpendicular. Then what is the value of P1? Root 2 sec theta divided by root 2 minus tan theta upon 1 upon root 2 whole square plus 1 square whole square root. This is the value of P1. Similarly, find out the value of P2. Length of perpendicular on the second asymptote, you will get sec theta plus tan theta upon 1 upon 2 plus 1 whole square root. That is the value of P2. Now product of their perpendiculars. It means P1 into P2. So what is the value of P1 into P2? Multiply these two. You will get sec square theta minus tan square theta upon, multiply the denominator, you will get 3 upon 2. So now sec square theta minus tan square theta is 1. So it becomes 2 upon 3. So that is the value of length of perpendiculars. Now check which option is your correct. So you can see D option is the correct option.